next example of PDA, we will be looking at this example. So the question states that design PDA for the language L is equal to WCWR such that W belongs to A comma B the whole star, where WR is the reverse of the string W, and show ID, the instantaneous description for the string ABCBA. So what we are saying is, if you have a string say ABAB, the reverse of the string will be BABA. So this has to be accepted. So if you take a simple string, so ABCBA. So C, if you read C, so once you read C, the reverse of the string will start. So this has to be accepted. This has to be accepted. So we will look how the stack actually works for this kind of strings. So for this kind of strings. So Z0 is the top stack element. You are reading A as the input symbol. So A goes to the stack. Now you are reading B. Now you are reading B. Unlike pushing or popping the different elements, you will push everything to the stack. You will simply push everything to the stack until you encounter C. Until you encounter C, you will simply be pushing everything onto the stack. Let it be any order of A's and B's, you will simply pushing into the stack. Now when you encounter C, you have understood that W, the string W is completed. Next, whatever you are receiving would be the reverse of the string, the reverse of this string. So when you read B, what will happen? You have to pop the same B from the stack, because reverse of the string means the string and the reverse of the string should be equal. So when you read B, stack also should have B, then you have to pop it. Then when you read A and top stack element should also be A, then that string is present in the language. Next, when you reach the end of the string, that is epsilon, and Z0 is the top stack element. So what do? You accept the string by the PDA. And if you want to work for this particular example, we'll just take that example. We'll just take this example. Z0 is a top stack element. So we are just reading this A. So push that onto the stack. I told you, until you encounter C, you'll push all the elements into the stack without even seeing the order. So B you are reading, just push it onto the stack. A you are reading, push it onto the stack. Again B you are reading, push it onto the stack. Now when you read C, you understand that okay, now I need to be popping the next coming elements. So B has to be there in the stack, then only you will pop it. A has to be there in the stack, you will pop it. Again B, pop it. Again A, pop it. And when you reach the end of the string epsilon, you need to have Z0 as the top stack element. Then the string and the reverse of the string is present in the string. So it can be accepted. It can be accepted by the PDA. So we will take an example of which does not belong to the language. So now for example, I say ABA, CBA. This is a string W, but this is not the reverse of the string W. So this ideally should not be accepted. So we will see what happens with the stack. So Z0 will keep pushing everything onto the stack. So when it reads A, B, A, it will simply push it onto the stack. Now it encountered C. So next, whatever element it reads, corresponding element if it is present, then it will start popping. So you are reading B, but A is in the top stack element. You are reading B, but A is in the top stack element. So you need not accept it. You should not accept this. You should not accept this, and this will not work. So you will not accept this by the PDA. So this is how you have to write the or design the PDA for the given language. So, we will design the PDA for the language WCWR. So, we have seen how it works with the stack. So, we will just look into how we design the PDA. So, we shall start with the state, initial state Q0. So, Q0, when it reads A as the first input symbol, what should happen to the stack? So, stack is Z0, we will simply push that A to the stack. A to the stack. So, you will just mention that in the A Z0, A Z0. You will just simply push it onto the stack. So, next you have B and A is in the stack. What will you do? You will simply push it onto the stack. As I said, whatever comes before C, you will be simply pushing onto the stack. So, what is the other possibility? You can have BA, C, AB. So, B also can be the first input symbol. B also can be the first input symbol based on this string. So, you need to accept that also. So, B being the first character, you simply accept it. You simply accept it. Next, you might encounter B or A upon A and B. So, you need to accept that also. You need to accept that also. So, that transition will be represented using A. A is the input symbol and A can be in the stack. So, what will you do? You will simply push it onto the stack. This is the push operation, we will simply push it onto the stack. So, next A is the input symbol. You might have B in the stack. You might have B in the stack. So, that possibility also should be covered. So, B in the stack then. So, this is B is in the stack. You will be pushing A to the stack. BA, A is the top stack element. You will be pushing B to the stack. B is the input symbol. Sorry, B is the stack symbol which is already present. B will be pushing onto the stack. So, this is what you do for all the input symbols until you encounter C. But when you encounter C, what will happen? So, since the question says W belongs to A comma B the whole star. So, the question says W belongs to A comma B the whole star, then what is the possibility? We can either have C as the input string, or we can have ACA or BCB, something like this. The string starts like this. So, if you have only C, that also should be accepted, but your stack symbol should be Z0. So, that particular transition we will mention it here. Why are we going to the next state? Because after accepting C, you will start popping. You will start popping whatever you receive. Whatever you receive, you have to start popping the popping operation. So, C and Z0 is the top stack element. Z0, you will reach the state Q1. And if C is the input symbol, and B, or you can have A in the stack. So, in this particular example, if you see Z0, B is pushed, A is pushed. The top stack element is A when you encounter C. And in this example, when you encounter C, top stack element is B. So, you can either have A, B or Z0. So, you should write all the three possibilities. C upon A, it has to keep A as it is. Keep A as it is. You need not perform any push or pop operation. No changes to the stack. Because when you encounter C, you just understand that, okay, W string is over. Next we will be receiving WR. So, next B. So, B will be as it is. Then you go to the state Q1. So, once you reach Q1 state, you need to start popping, right? So, when you receive B, B should be the stack, you will pop it. Or when you receive A as the input symbol, A only should be in the stack, so you will pop it. So, we will write that transition. A is your input symbol. A only should be in the stack, then you will pop it. Similarly, B, you will pop it. So, same symbols should be popped. Different symbols means that does not belong to the string or the language, so you should not accept it. So, next for B is popped out. For A is popped out. When you reach the end of the string epsilon, what should be there in the stack? Z0 should be there in the stack. So, you will reach final state. So, epsilon Z0, you will keep Z0 as it is and you will reach final state Q2. So, we already know everything should be accepted and pushed onto the stack until you encounter C. So, we will write the transition function. Delta Q0 is the state, and if you read A upon Z0, then you simply push it onto the stack according to this transition. So, next transition we will write BZ0, Q0 is the state, B is the input symbol and Z0 is the top stack element. What do? You push it and stay in the same state Q0. So, Q0, B, Z0. Similarly, for these, delta Q0, A, you will simply push it onto the stack. AB, Q0, B, A is the input symbol, B is the stack element. So, what do? Stay in the same state, AB, you push it onto the stack. Next, for this transition, delta Q0 is the state, B is the input symbol, A is the stack, Q0 is stay in the same state, BA, you will just push everything to the stack. Delta Q0, BB for this transition. So, next you have these three transitions. So, if you accept C upon Z0, you have to keep the stack as it is. So, you will write the transition for it, Q0, C, Z0, Q0, Z0. So, next delta Q0, this C, keep A as it is, no changes to the stack. Delta, this transition, but you change the state, right? You change the state, you need to write that. To which state you move. So, if you read Q0 C, if you read, you are changing the state to Q1, that you have to mention here Q1. So, you are changing the state to Q1. So, Q0 is reading C and B is in the stack. As per this, you keep B as it is and you change the state to Q1 Next, these transitions you have to mention. You are in state Q1, you are reading A and top stack element should be A itself. So, A, Q1, epsilon. So, popping the element is represented using epsilon. Next, Q1, B, Q1, epsilon. So, these two are done. Next, from Q1 you read epsilon and you go to Q2. This you have to write it carefully, Q1 and you are reading epsilon and top stack element should be Z0 itself, and you will reach final state Q2 and keep the stack as it is Z0. So, you have reached the final state. This is the transition function for the said PDA. The given language, this is the transition function, this is the transition diagram. As I said earlier, in the exam you have to write both transition function as well as transition diagram. So next in the question it states that you need to write the sequence of moves made by the PDA for ABCBA. So ABCBA, you need to write the ID, that is the instantaneous description for ABCBA. So we shall start writing it. So you are starting the state, from initial state, that is Q naught, and the string is ABCBA, and what is there in the stack? Z naught will be initially in the stack. So next what do? Q naught is reading A. Q naught is reading A and Z naught is on the top of the stack. So as per this transition, you will stay in state Q naught, and the remaining string is BCBA, and A is pushed onto the stack. So next Q naught is reading B, A is in the stack. So as per this transition, you will simply stay in the same state Q naught, remaining string is CBA, and you will simply push it onto the stack. Irrespective of what is there in the stack, you will simply push it onto the stack. Next, Q naught is reading C and B is in the top stack element. So what will happen? As per this transition, you will simply move from state Q naught to Q1. You will simply move from Q naught to Q1. So write Q1, write the remaining string which is BA, and what do? You do not do anything to the stack, you will just keep B as it is. So BAZ naught remains the same. This is important. So BAZ naught remains the same. Now you are in state Q1. Q1 is reading B and stack symbol is B. So yes, we have the transition here for state Q1. B is the input symbol, B is the stack symbol. What do? You pop. As per this transition, you pop. So Q1, you will stay in Q1 as per the transition, and A is the remaining string. You will pop this B and remaining will be AZ naught. Next, you are reading A upon Q1 and A is the stack symbol. What will happen? As per this transition, you will simply pop it. So you will stay in state Q1. You have reached the end of the string. So end of the string means remain with epsilon, and you will pop this out. So you will remain with Z naught. Now Q1 is reading epsilon upon Z naught. So this particular transition, Q1, it goes to Q2. So write that Q2, and the remaining string is epsilon itself, and what do? You keep it as it is. So Z naught, and you have reached the final state. Q2. So this is acceptance by final state method. So if you want to do it by empty stack method, just empty the stack by using epsilon. Empty the stack by using epsilon, and mention the same here. You will be accepting it by empty stack method.